Imagine, if you will, a place where humanity actually builds its own miniature Big Bangs. Now, this place isn't just a flight of fancy, it's real. It's called CERN, the European Organization for Nuclear Research. Deep beneath the border of France and Switzerland, there's this absolutely magnificent machine. It's the Large Hadron Collider, or LHC. Picture a circular tunnel stretching for 27 kilometers, filled with powerful magnets and advanced detectors. Honestly, it's one of the most complex scientific instruments ever created by human hands. Its purpose sounds simple, but it's actually quite profound. To understand the fundamental rules that govern our entire universe, from the tiniest particles to the largest galaxies scattered across the cosmic dark. So you might wonder, what exactly happens inside this giant ring? Well, scientists take tiny particles, protons, which are, in a sense, the hearts of atoms, and accelerate them to incredible speeds, almost reaching the speed of light. These particles race around the tunnel in opposite directions, guided by thousands of superconducting magnets. Then, at certain points, these beams of particles are made to cross paths. They collide with enormous energy, shattering into a shower of even more fundamental pieces. It's a bit like smashing two very complex watches together just to see the tiny gears and springs that make them tick. In these fleeting high-energy moments, we catch a rare glimpse into the building blocks of everything. But why go to all this trouble? The answer really lies in our unending curiosity. We're a species that looks up at the stars and asks, what are they? We look at ourselves and ask, what are we made of? These experiments at CERN are our way of seeking answers to these ancient questions. Scientists are searching for particles and forces that we know must exist, but have never actually seen. They're testing our most cherished theories about reality itself. Each collision is like a question posed to the cosmos, and the resulting debris is the universe's whispered answer, which our detectors carefully record and study for years. This whole quest is about filling in the blank pages of our cosmic story. We have a good model of physics, but it's incomplete. It doesn't explain everything we observe. For example, it doesn't tell us what dark matter is, the invisible substance that holds galaxies together. It doesn't fully explain the force of gravity in the same way it explains other forces. CERN's experiments are designed to push the boundaries of our knowledge, to find the cracks in our current understanding. By creating conditions that haven't existed since the very first moments after the Big Bang, we hope to uncover the missing pieces of the puzzle and perhaps see the universe in a completely new light. One of the most mind-bending ideas that physicists explore is the existence of other dimensions. Now, we're all familiar with the 3 dimensions of space length, width, and height. You can move forward and backward, left and right, and up and down. And of course, we also experience a 4th dimension, time, which carries us relentlessly from the past into the future. But what if there are more? Some advanced theories in physics, like string theory, actually suggest that there could be many extra dimensions, curled up so small that we can't see or interact with them in our everyday lives. They could be all around us, hidden from our senses. Scientists at CERN aren't intentionally trying to build a gateway to another world, not exactly. Their goal is much more grounded in physics. They're looking for evidence that these extra dimensions might actually be real. The logic behind this is absolutely fascinating. If these other dimensions exist, it's possible that a tiny fraction of the energy from a powerful particle collision could leak into them. Think of it like striking a drum. Most of the sound travels through the air to your ears, but some of the vibration travels through the floor. In the same way, if energy seems to vanish from a collision, it might not be gone. It might have just slipped into a dimension we can't perceive. This is where the idea of a portal comes from, though scientists would certainly use more technical terms. A portal, in this context, wouldn't be a shimmering door like you see in science fiction. It would likely be a microscopic, fleeting disturbance in the fabric of space-time. Imagine a tiny temporary wormhole, smaller than an atom, that connects our dimension to another for just a fraction of a second. It wouldn't be something you could step through. Instead, its existence would be inferred from missing energy, or the appearance of strange, unexpected particles that could only have come from another dimensional space. The search for these phenomena is honestly a long shot, a true exploration into the unknown. It requires sifting through data from trillions upon trillions of collisions, looking for that one event that doesn't fit our current theories. It's the ultimate search for a needle in a cosmic haystack. Finding evidence of extra dimensions would be a discovery on par with realizing the Earth revolves around the Sun. It would fundamentally change our perception of reality. It would mean that the universe is vastly larger, stranger, and more complex than we ever dared to imagine. A place with hidden realms just beyond our reach. Let's for a moment allow our imaginations to wander. What if one day the unthinkable happens? What if an experiment at CERN actually creates a stable macroscopic portal? What would we see? It might not be a swirling vortex of color. It could be something far stranger. Perhaps it would look like a perfect sphere of blackness, absorbing all light. Or maybe it would be a window showing a sky with two suns, or a landscape with bizarre alien geometry that honestly hurts our eyes to look at. The laws of physics in that other dimension could be entirely different, leading to colors we've never seen, and structures that defy our understanding of gravity. The experience wouldn't just be visual either. Imagine the sensations. Would we feel a strange pull, as if the gravity of another universe were tugging at us? Perhaps odd sounds would emanate from it, not carried by air but by fluctuations in space-time itself. Maybe a cosmic hum or a series of clicks and tones that sound like an alien language. The air around the portal might even feel cold as energy flows from our world into the other. We might detect particles that have no place in our universe with properties that defy all known rules of physics, offering us the first tangible proof that we aren't alone in the cosmos. The first things to come through the portal probably wouldn't be creatures but raw information or energy. We could see light from stars that don't exist in our sky. We might receive patterns of energy that, when decoded, reveal the fundamental constants of that other universe. Are their atoms stable? Is their speed of light the same as ours? These are the first questions we would ask. It would be the greatest scientific discovery in human history, a direct line to a separate reality. We would become cosmic explorers without ever leaving our planet, peering into a realm with a different story and a different set of rules. Of course, the possibilities are endless and could span from the benign to the terrifying. The other dimension could be a void, empty and cold. It could be a chaotic inferno of energy incompatible with our form of matter. Or it could be home to life, but a form of life so different from us that communication would be impossible. The portal could be a one-way mirror, allowing us only to look. Or it could be a two-way street, raising profound questions about security and the unknown consequences of making contact. The very act of opening such a door would force humanity to confront its place in a much larger, more populated multiverse. The opening of a portal to another dimension would instantly reshape our world. Science, philosophy, religion, and art would all be transformed overnight. The discovery would be the ultimate confirmation that our reality is just one of many possibilities. It would shatter our sense of cosmic loneliness and at the same time introduce a new, profound sense of vulnerability. Suddenly we'd have cosmic neighbors and we'd have no idea what their intentions or even their nature might be. Governments and societies would have to grapple with questions that were once the sole domain of science fiction writers and dreamers. The long-term effects would be staggering. If we could safely exchange information or materials, it could lead to a technological revolution beyond our wildest dreams. Imagine accessing new forms of energy, new elements with impossible properties, or medical knowledge from a civilization that has existed for billions of years longer than ours. It could solve all of our worldly problems, from disease to scarcity. We could learn about different ways for life to evolve, different solutions to the challenges of existence. Our entire civilization's trajectory would change, pointed toward a future integrated with at least one other universe. However, the change would also be deeply personal. How would you feel, knowing for certain that entire universes exist alongside our own? It would reframe our sense of purpose and meaning. Our struggles and achievements on Earth would seem both smaller and, in a way, more precious, as our unique contribution to a vast cosmic tapestry. It would inspire a new generation of explorers, not of oceans or planets, but of dimensions. The drive to understand and to see what lies through the portal would become the single greatest motivator for human endeavor, uniting us in a common cause. This is why we explore these ideas, even if they seem fantastical. The search for knowledge is what truly defines us. Experiments at CERN, whether they find new particles or hint at new dimensions, are expressions of our deepest impulse to understand our home. We are the universe trying to comprehend itself. While a portal to another dimension remains a distant, speculative idea, the very act of considering it pushes our minds forward. It encourages us to ask big questions, to challenge our assumptions, and to continue our grand and beautiful journey of cosmic discovery. The quest itself is as important as any destination.